recording, and here we go. So, for your do now today, I gave you a little review of what we did yesterday just to see how well it stuck. And honestly, based on your exit ticket scores, guys, I was very impressed. Nobody got anything too terribly wrong. You guys did really, really well. I want to say about 90% of you got 100% on that. Like, that is incredible. So, a little round of applause for y'all. Very, very proud. Very proud. So, let's look at this do now. For number 1, I have 2x times the quantity here of 4x to the third power minus 2x. Whenever I have a number or a term that is outside of some terms in parentheses, what operation are we doing? Multiplication, distribution, absolutely. So I like to start by drawing my arrows just to show what I'm doing there. And let's start with the first problem. I've got 2x times 4x to the third power. What did you guys get for the first part? 8x to the fourth power. So I'm going to write 8x to the fourth power. Did anybody not get 8x to the fourth power? What'd you get instead? Anybody feel like sharing? Did anybody get 8x to the third power? I bet some people did, yes. So whenever we are multiplying our variables that have exponents on them, remember what we're really doing is taking our x, and we know that if we don't have an exponent, we assume that there is an invisible 1 right here. So we're going to add the numbers attached as an exponent when we multiply. I've got x to the first power plus the third power. That's going to give me my 4, guys. Everybody see that? So remember, the exponent rule we talked about yesterday is when you multiply exponents, you just add their numbers together. Okay, so we've got 8x to the fourth power. What's the next part we do? Yeah, so we're doing 2x times negative 2x. And I heard somebody say it, minus 4x to the second power. So would somebody like to explain to me how we got negative 4x to the second power? Yeah, we've got a positive 2 times a negative 2. That's going to give us a negative 4. So we got that part. And then we're doing x to the first power times x to the first power. And what is 1 plus 1? 2. So our answer here, we will circle it, 8x to the fourth power minus 4x to the second power. Good. We have any questions about number 1? All right, let's look at number 2 then. Same kind of problem. I have 5x to the third power times this whole quantity, negative 2x plus 3. So my first step, I always like to draw my arrows. And let's do our first part of this problem. Who would like to explain to me how I'm going to find 5x to the third power times negative 2x? Yeah? Multiply. Tasha, do you want to walk us through it? I saw your hand up.
Yes, ma'am.
All right.
I'm going to do 5x to the third power times negative 2x.
Mm-hmm.
It's going to give us negative 10x. And you're going to add the 3 to the invisible 1. That's the negative.
Yes.
You're going to do negative 10x to the fourth power.
Yes, thank you. You explained that beautifully. We did 5 times negative 2, and that gave us negative 10. Then we did x to the third power times x to the invisible 1, If there's no power there, remember there's an invisible 1. And we did 3 plus 1 and got x to the 4th power. Very nice. Okay, who can tell me about the second half of this? Say that again. Perfect. So we're going to take 5x to the 3rd power, multiply it by 3. What's that going to give us?
15x.
Good. 15x to the what power? 3rd power. 3, the plus 3 in our original expression, there's no x on there, so we don't need to change our exponent that's attached to our variable. Okay, and now guys, we circle our answer. That is it for number 2. Do we have any questions about either number 1 or number 2 before we try 3? Any questions? Okay, we will move on to 3 then. So we have now a different kind of problem. I put this on here just to see if anybody would, you know, not get into that auto mode where you're just kind of doing the same thing over and over. I want you guys to be able to recognize that this is a different kind of problem. And we did this yesterday. So I've got 5x to the 3rd power plus 2x minus 3x to the 3rd power minus 4x. Who can tell me what I'm doing here? What should I be doing? Yeah, we're just combining like terms. Nowhere in this problem does it tell me to multiply. Nowhere does it tell me to do that. I just have pluses and minuses. So to start a problem like this, I always go left to right. I'm going to look and see what my first term has attached to it. My 5 has an x to the 3rd power. So where else do I see x to the 3rd power? Yeah, I've got negative 3x. I've got minus 3x to the 3rd power. So I'm going to circle that other x to the 3rd power. And remember, when we're doing these, I'm not trying to figure out 5 to the 3rd power or negative 3 to the 3rd power. I'm not doing anything like that. My power is connected to my variable, not my number. Okay? So I've identified my like terms for x to the 3rd power. What other terms do I have in this expression? Yes, I have terms that have x's. I've got 2x and I've got minus 4x. So let's write out kind of the work that you would be doing in your head maybe, or if you prefer to write it out, you can write it out, absolutely. So whenever I have my terms that are the same, I am combining them and I'm kind of rearranging this expression in a way. I'm going to bring down my 5x to the 3rd power. And what else should I bring down? Just 3x to the 3rd power? Yeah, there's a minus sign there. We want to bring down the signs too. Minus 3x to the 3rd power. So we've got that. And what else should I bring down next? Yeah, perfect. Plus 2x and minus 4x. There we go. Now, what do I do here? Yeah, that's right. I've got 5x cubed, so to the 3rd power you can also say cubed. 5x cubed minus 3x cubed. What's 5 minus 3? 2. X cubed. Don't lose your variable, don't lose your exponent. And now what is 2x minus 4x? Negative 2x. So what should I write beside 2x cubed? Yes, minus 2x. And that is my answer. I'm going to circle it. Very good. If you got all 3 of those, give yourself a pat on the back. That is wonderful. Very nice job. If you just missed one or two little things, that's also great. We are all learning together. That's wonderful, guys. Okay. That is so good. Now, let me pull out my notes from yesterday. We are going to do some more review today. We're still going to make sure we've got all of our skills so that we are ready for all the Algebra 2 that's going to follow. Now, I have these somewhere. Hang on. So go ahead and get your notes out from yesterday. I'll put it over here.
Do we turn these in?
Say that again?
Do we turn these in?
The do now? No. You keep that for your notes, so like you make any corrections along the way when I reteach it, you keep your do now, but you being here and me like visually seeing you work on it, that's how you get your participation points. So if you're here and you're not trying, like you're just sitting there and nothing's on your paper, you won't get the participation points for today. All you got to do is attempt it. Even if it's wrong, you get all your points. So let me pause this real quick because I actually... So yesterday, I'm going to pull my notes out. Remember, we did practice doing kind of exactly what we did for our do now. We did combining like terms. We talked about how when we have things where we're just combining terms with like x squared and x, you can almost think of it as shapes or colors or different categories that you're adding and subtracting to not get you as confused with the x and the squared, because we're not actually doing anything with those. They're just attached to our numbers that we add and subtract. Okay? So after we did that, we moved on and talked about how to do distribution, or the distributive property, where you multiply the outer number by each of the numbers inside, or each of the terms inside. We talked about the rules of exponent multiplication, where you add the numbers of the exponent when you multiply. Just like that. You guys remember all that? Good deal. We did a couple practice problems, and then that is where we landed. So, now, let me cross this off because this is not the right day. We're going to move on to one step further, and we're going to talk about simplifying expressions that have both of these things in them. We've got distribution and we've got those combining of the like terms. So if you want to get a page of notes out or just attach it to the end of what we did yesterday, go ahead, and I'll let you guys have a moment to get these two problems written down so you're not playing catch up while I'm trying to explain. And I'll pause this for a moment. Okay, so we're going to start with our first problem here. I'm going to move this over so we can see it. I have 3 times the quantity x plus 4 plus 2 times the quantity of x minus 1. So whenever we have multiple different operations happening here, remember operations are just things you do to numbers. That's multiplying, dividing, adding, subtracting, those things. That's an operation. We have a lot of different operations happening here. So we need to remember our order of operations. I've got a poster right above the thing up here, above the board. We want to think about what we should do first. So, what should we do first? Yeah, well, we see in our order of operations, that's like our PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Parentheses comes first, right? Yeah, parentheses are first. So I have x plus 4 and I have x minus 1, but we don't know what x is, right? So we can't do that yet, correct? Yes, Bree.
So are we going to do?
Yes.
Okay.
Yes. So whenever we can't solve what is inside the parentheses yet, that's when we do that distribution first. So we're going to multiply. 3 times x and what? And 3 times 4. Good. So first off, what is 3 times x?
3x.
Good. 3x. What is 3 times 4?
12.
Good. 3x plus 12. Done with that part. Now let's move on. What are we going to do in the second half here? Yeah, same thing. 2 times x. I'm going to bring down this plus sign. Plus 2 times x, which is 2x. And what is next? 2 times negative 1. What's that? Negative 2. And so to do that, we're going to write minus 2. Minus 2. Okay, so we have done our distribution and we are to here. Our answer so far should read 3x plus 12 plus 2x minus 2.
So now we can do like terms.
Yes, now we need to continue simplifying. So at every step we need to say, is this in the simplest form? Is this condensed? And is everything combined as far as we can go? And in this case, no, it's not done yet. We still have 2 different terms with x's. We've got 2 terms without x's. So we can take it further. We can combine. So let's go left to right. I've got a 3x. Here's an x. Where else? Yeah, 2x. Good. So let's rearrange this. We're going to put these together. 3x plus 2x. And what's 3x plus 2x? Yeah, 5x. Good. 5x. Okay. Now we need to do the next half. What am I bringing down this time? Yeah, plus 12 minus 2. And yeah, I just heard, CJ, you said it. 12 minus 2, that's 10. Perfect. Now, is it a positive 10 or a negative 10? Positive. So I'm going to put a plus sign in between my 5x and my 10. 5x plus 10. Can we simplify any further from here? No, that's it, guys. That's it. So we circle our answer. Circle your answer. 5x plus 10. That is as simple as we can get it. Very nice, guys. Any questions about that first one? Some of this should be feeling a little familiar. Little familiar. Okay. Let's go to the second one now. So, on my second expression, I've got in parentheses 2x plus 3 plus 4 times the quantity of 3x minus 1. What do I do here? Okay, so what's happening? Are you talking about the first parentheses here?
It's like an invisible one, so you pretty much do the same.
Yeah, exactly. So guys, first of all, this is in parentheses. There's not necessarily anything to distribute, but I guess if you wanted to think of it this way, there's like an invisible 1. I distribute an invisible 1. That's going to make it stay the same. Anything times 1 is itself. So we're really not doing anything here. We can't combine these because x is not like with a number without x. We've got 2x plus 3. We can't combine those. So we're going to move forward and see what we can do. I've got another set of parentheses. I'm going to distribute. Yeah. So let's do 4 times 3x. 4 times negative 1. What's happening?
4 times 3 is 12.
Yeah, 4 times 3x is 12x.
No.
Ah, you caught yourself. Good job. 4 times negative 1 is? Negative 4. Good. Very good. Are we done? No. Not yet. So what should I do from here?
Bring down the other one.
Yes, we want to keep it nice and neat. I want to bring this down, and we really don't need those parentheses. So I'm going to get rid of them. Okay, we don't need them because there's nothing happening inside of here. So I'm going to write beside this 2x plus 3. And what goes in between my 3 and my 12x? Plus, because 12x is positive. Sorry, I made that kind of messy there, but you know what I meant. Now you combine like terms. Where are my like terms? Yeah, I've got 2x plus 12x. What's that? Yeah, I'm going to write this out. You don't have to, but I wrote 14. My goodness, guys. I'm getting ahead of myself. Okay, sorry. 2x plus 12x, and underneath I'll write that 14x. And then I had plus 3 and minus 4. Awesome. Oh, there. Plus 3 minus 4 is negative 1. So what do I write beside 14x? Yeah, minus 1. And can I do anything else here? No, I'm done. So I'm going to circle my answer. Very, very nice. Okay. So we just ran through a few of those together. I would now like for you guys to do these next two on your own. I want to see how we can do this on our own. I'm going to pause our video and I'm going to set a little timer for you. Okay, we are back. Let's look at these. Okay, so for the first one I had you do on your own. Who wants to tell me what I should do first? Yeah, I hear it. Distribution. We're multiplying. So what am I multiplying?
3x.
Yep. 3x times 2x. What is that? 6x to the second power. Good. Remember, 3 times 2 is 6. X times x is x squared. X times x is x squared. Very good. Okay. Now, what am I doing next? Yeah. 3x times 5. Good. So that is plus 15x. 3 times 5 is 15. X times, well, there's not another x, so we just bring it over. 6x squared plus 15x. That should be the first part of our answer. Okay. Any questions about how we got to this point? Good, good. Okay, so let's look at the next part. I've got plus 2 times the quantity 3x minus 4. What am I doing here? Yeah, 2 times 3x. Good. So plus 6, because 2 times 3 is 6, and the x, it just stays. 6x. And 2 times negative 4? Negative 8. Very good. Okay, so we are to this point. We've got all of our terms separated. We want to make sure that we are completely simplified. Is this expression simplified? No. No. What do we need to do? Yes, we have like terms here in the middle. I've got 15x plus 6x. So we want to combine those. What is that going to give me? 15 plus 6? 21x. Now, is it 21x or 21x squared? Let's think about it. Let's think about it. If I have 15 x's and I add 6 more x's, that's going to give me 21 x's. I only added. When I multiply, that's how the x turns into an x squared. Okay, whenever I just add an x, I'm just getting more x's.
I forgot my exponent, so I got 27.
You got 27x?
Yeah, I forgot the exponent, so I added the other 6.
I know how they got it. So they were adding all the, and I even put the second time around I did it to the 4th power. When we're adding, we don't have to put to the power. They just become 1.
Yes. Guys, I'm going to show you something visually. Hang on, let me get this out.
I need to write that down.
Okay, so guys, these are called algebra tiles. I made them order for you. I made everybody get these, so we'll play with these eventually. But let's talk about something. Here is what we're gonna call X. Here is another X. Okay, here's another X. We're gonna say, like, once we get so many X's, we're really just counting, like, here's 1X, here's 2X, here's 3X, here's 4X. What if I did X times X? Here's what that's gonna look like. Instead of lining them up and saying that we're just increasing our number of X's, so this would be 4X. Now I have X times X, and this is X squared, becomes that square. The only time that it is turning into a squared number or a different exponent is when we multiply, because we're saying that we want to line this X up as many times as itself to create that square. When we add, we're not changing the exponent in any way. I'm just adding 1x, 2x, 3x, 4x, 5x, 6x, okay? We're not changing the exponent. We can talk more about these later. This isn't going to make much sense without priming you guys and explaining what all of these are. But when we are adding, when we're combining like terms, does it make sense for us to go from x's to x squared? Our answer has to be a like term with what we add. We're not going to change the exponent. Okay, our answer has to also be like terms with the terms we're combining.
You gotta match up.
They have to match up. The only time that we are changing our exponent is when we multiply. When we multiply, we're not messing with like terms. You can multiply anything. You cannot add and subtract anything. Okay? They have to be like, so our answer is going to be like. The exponent will stay the same. Yes?
So when we go into the second step with, after it gets broke, I figured out the answer. We go into the second step. So the only thing we're going to mess with in that second step is the like term.
Yes.
All right.
Yes.
Okay.
So in step 1,
All right.
we are trying to get rid of parentheses.
All right.
I'll write that down, guys.
Yes, please.
So, step 1, remove parentheses. Okay, so this is also going along with our order of operations. You see parentheses comes first. Step 2, we're messing with exponents, okay? Step 2 is messing with exponents whenever we're doing that multiplication and division. So that's kind of grouping our next two in the order of operations. Oh man, I'm going off the page. Exponents and multiplication. Step 3, once you've gotten rid of all the parentheses and there's the exponents, we're not doing any more multiplying, so we've got them what they're gonna stay. You're just doing that adding and subtracting. We're just following the order of operations. Okay, so there's a little step-by-step guide.
Are we gonna get cheat sheets
What you mean, get cheat sheets?
like you did for us last term?
It depends on what kind you're talking about. What I have found has been the most helpful is instead of me making the cheat sheets, having you guys make them with me. So like I will write it out and you guys copy it down because it sticks in your brain better when you're the one writing it. But absolutely, you can always tell me if there's something you want to have a cheat sheet on, we can go through and make one together. 100%. Absolutely. Like especially whenever we get to factoring, we're going to make some cheat sheets because that one is tough.
I just need to remember to only add the like term after going to the second step.
Right, and we want to think about this. If my parentheses are gone, why would I multiply anything? There's nothing that tells me to multiply. We just have pluses and minuses. Good. Good, good, good. Okay, guys. So we combined our 15x and our 6x and got 21x. And I heard some people say that they got 27x because whenever they did 3x times 2x, they forgot to make it squared. So what happened there is they did 21x plus 6x, even though it should have been 6x squared. So that's all right. We're going to finish this problem out. So I combined those, and now I just am going to bring everything down. I've got 6x squared.
See? I'm sorry.
What's up, Tasha?
See, I didn't do what you said. I did the 6x squared and all of that.
Mm-hmm.
And what I did is when I was saying out, what I was doing, I was saying that I do this, I was putting the 1 and stuff, I was putting exponents there.
Uh-huh.
And the x's and putting, that's what messed the whole problem up for me. I see exactly what I did. Exactly.
Well, good. I'm glad you see it. So I want to understand what you did in case somebody else did the same thing. So did you...
I did 6x squared. I got it to, I broke it down to that, the 3x, 2x.
Uh-huh.
I got 6x, and I got 6x squared. So,
Perfect.
I added that. I did the 3x plus the 5, which got me 15x, and then I put a 1 right there.
Ah.
And I also did that when I got the
For your
plus
6x?
One to the other one. I did a 6, then I did a 6, 1. I did the parentheses, that's what messed me up altogether. Then, when I did all that, I got a negative 8. And whenever I went into doing it, and I messed up at the 6x squared plus 15x, and since they had squares, I did those together. I did 6x squared, 15. I added it all together, and it got me 27 to the 4th power. It messed me up.
Okay, so what you did, I see now.
Yes.
You wrote a 1
Yes,
for your
yes,
15x,
yes,
for
I
your
did.
6x,
Yes.
and when you combined those, you thought, oh, 1 plus 1 is 2,
Yes.
so it's 21x squared.
Yes.
And then you saw, okay, 21 plus
Yeah.
6
Yeah.
is 27, 2 plus 2 is 4,
Yes.
27 to
That's
the 27x to the 4th power.
That's exactly what I did.
I
That's
see
exactly what I
now.
did. Yeah, I see
Okay, so yes, just remember, anytime that we are multiplying exponents, that's when they get bigger. When we're adding numbers that have variables and exponents, we don't touch them. We just pretend like what we did yesterday where I said it's just like a green circle and a blue circle or a yellow circle, and we're just combining circles, you know? Okay, awesome. Awesome, I'm so glad you figured that out.
Me too.
Okay, so we're almost there. 6x squared plus 21x minus 8. We got to bring that down too. And we can't go any further. That is our answer, guys. That is our answer. Does anyone else have a different way that they made a mistake that they might want to share? Or is anyone confused still and have a question? We can talk about it more.
I have a question.
Sure.
So when it's 3, at the very top where it's 3x and then the 2x is subsequent,
Mm-hmm.
it's we only add it if it's both x if there's no variable.
Yes, yes. So we did 3 times 2 is 6. X times x is x squared. So anytime you take something times itself, we're squaring it. Like 5 times 5 is 25. 5 to the 2nd power, or 5 squared, is 25. It's the same thing. You know, 2 times 2 is 4. 2 to the 2nd power is 4. X times x is x squared. Okay? Yes?
Can I go over
Yeah, absolutely. Go ahead. Yeah, if you guys ever need to step out of the room for any reason, use the bathroom, make a call, whatever, you don't have to ask me. You can just go. That's all right. I do appreciate you asking, but you don't have to. It's all right. Okay, any other questions? I'm happy to take them. Okay, let's try this next one then. What am I gonna do here first? Distribute. Yes, we're trying to get rid of these parentheses by using distribution. We're multiplying, guys. So we'll first do this. 2 times 4x. What is that going to give me? 8x. Good. So let's write that. 8x. What about 2 times 3? 6. Okay. Now, what do I do next? Oh, thank you for saying negative 3x. There's a minus here, so this is a negative times all of these. We're going to do negative 3x times x and negative 3x times 1. What is negative 3x times x? Negative 3x squared. Yes, negative 3x squared. Then what? It's just negative 3x. Anything times 1, that's not going to change it. It'll just stay the same. Negative 3x times 1 is negative 3x. Okay. We are here now. I've got 8x plus 6 minus 3x squared minus 3x. Let's go left to right and make sure that we are done, or make sure if we've got things to combine, we know what we're combining. So guys, we are now to that step 3. We're just adding and subtracting here. We did all our parentheses. So let's start with the first term. I've got 8x. Do I have x by itself anywhere else?
3x.
Oh yeah, negative 3x minus 3x. So let's rearrange this and write those beside each other. I've got 8x.
That's where I stopped.
I gotcha. Well, you made it pretty far. That's good. That's good. 8x, and what am I writing beside it? Yes, negative 3x or minus 3x. Perfect, which, yes, 8 minus 3 is 5. So we've got 5x. I'll write that beneath. And what else? Yeah, you're both right. Nothing else to combine. We're going to bring it all down. So I have plus 6 still. I'm going to bring that down here. I've got minus 3x squared. And that's your answer. Now this next thing I'm going to show you, this is optional. Eventually it won't be optional, but right now it's optional. We don't have to do it. But typically whenever we have an expression with powers in it, we like to put those powers in order whenever we write it from the biggest one down to the smallest. Yes? So we did the negative 3x times x. So we know that this is really 1x. It's like an invisible 1 there. So negative 3 times 1 is negative 3. X times x is x squared. Okay? Does that make sense, or do we want to talk about it more? I'm happy to talk about it more. Okay. So that 3x squared, that negative 3x squared, it came from that original problem up there. And then we just brought it down to the end. So whenever I'm talking about, this is that optional part, in our answers, we like to put our exponents in descending order, meaning going from biggest to smallest. So in descending order, I would write negative 3x squared plus 5x plus 6. These are just, oh yes, on those folders, yes, yes. So those are going to go up there on that little chart on the wall. And I put a little cup of Sharpies near that chart so that you can write it with a thick marker if you want. And that is where I'm probably going to start trying to put things that you missed, worksheets, maybe graded work coming back. I'm still kind of figuring out what we're going to do with those. I'm going to have to talk to Trisha about it because she uses them. So anyway, I would accept both of these answers. Right now I would accept both because these are both correct. This is just a different way to write it in a different organizational way. Okay? Any questions about that? Yes?
The way you wrote it, so like when we get into algebra 2, is that the way we have to write it or something?
Yes. Yes. I'm not expecting you to do that right now because we're not to algebra 2 yet. We're still doing the foundations.
Can you say that? Can you explain it again? What is
Yeah. Okay, so if you are curious, I'm going to re-explain it. We got our answer here. We got 5x plus 6 minus 3x squared. So what I did here is I just rearranged my answer and I put my term with the biggest exponent first. So minus 3x or negative 3x went here. And then my next biggest number, or not next biggest number, but my next largest, I guess, variable number would be 5x, because there's that invisible first power. So we've got 2, 1, and 6 doesn't have a variable, so it's going to go at the end.
So the number with the biggest variable goes first.
Yes.
And it goes down with that.
Exactly. So all I did here was rearrange my expression. Again, I'm not expecting you guys to know how to do this right now. We will get to doing this in more depth. I don't think it's something that's too difficult. I believe in you guys. You can do it. However, if you don't do it, I'm not going to mark your answer wrong. If you got this, that's correct. I will take that. Okay?
And you said you were recording other slides.
Yes.
Where can I find that at?
On Google Classroom. And are you connected on there yet?
Actually, I think I am.
Okay, and we can check before we go to lunch if you want. All right, guys. So lunch is in 5 minutes. We're going to go ahead and call this our halfway point here. I'm going to pause this recording. Okay, so we are going to run through a couple more problems just like we did before lunch. So I am going to give you, for example, let's do 2x times negative 3x squared plus 5 minus 3 times, let's do 4x to the third power plus 2x. Okay, so there's a lot going on here. A whole lot going on here. Let's make sure we understand every single step. So, whenever I am looking at any sort of problem or an expression, in this case we have an expression. Does anybody know what the difference between an expression and an equation is?
So the expression is just like the default how it is, and then when you work it out and you make it, that's like the equation.
Yes. So I'm going to repeat that. An expression is kind of like all the numbers and the terms written out together, and you're not solving for anything. We're not going to try and figure out what x is. When we simplify an expression, we are just trying to combine as many things as we can and get it to its simplest form. An equation is something like this, but with an equal sign, and where we're solving for our variable. We would be figuring out what x is. We are working with expressions, not equations, so we don't need to find x yet. Right now, we're just trying to make sure we understand how to combine terms correctly. So, first step here, what should we do? Distribute. Yes, I have 2x times something, so we're going to distribute first. So let me grab my pen. And I like to show distribution with those arrows. What operation are we using when we distribute again? Multiplication. Good. So what is 2x times negative 3x squared? Okay, negative. I hear a couple different answers. Let's go one thing at a time. 2 times negative 3? Negative 6. Good. And what's x times x squared? X to the third power. Good. Remember, we have x to the first power. That's an invisible 1. 1 plus 2 makes 3. So negative 6x to the third power. All right, we did the first part. Now what do we need to do? 2x times 5, what is that? 10x, good. And why aren't we changing that to an x squared or an x cubed? Yeah, exactly. There's not another x on that 5. There are no more x's that we multiply by itself. X is only being multiplied by itself once, so we don't need to change it. So 2 times 5 is 10x. There we go. All right, we have finished off this part here. And guys, something that I know has always helped me, and maybe it'll help you, as I finish completing parts of my expression and simplifying, sometimes it helps to just cross them off and say, I'm done with this. I'm done with this. Since I'm done with both of those, I'm also done with my 2x. And now I'm working with this, okay? So let's now go to the other half of our expression. We've got minus 3 times the quantity of 4x cubed plus 2x. Yeah. So what's negative 3 times 4? Negative 12. And what happens with my x cubed? Just bring it down. There's no x that I'm multiplying, so it stays the same. Minus 12x cubed. And now I got to distribute to the other term. Done with that one. So negative 3 times 2? Negative 6. Bring that x down. Good. Negative 6x. Awesome. Okay, guys. What do we do now? Yes, we need to combine our like terms. So first of all, let's figure out what our like terms are. We've got a negative 6x cubed and a negative 12x cubed. Those have the same variable and exponent. So what is negative 6x cubed minus 12x cubed? Yes, negative 18x cubed. Remember, whenever we are starting with a negative number and we are subtracting, it's the same thing as a negative plus a negative. When you add a negative, it's the same thing as subtracting. When you're subtracting, it's the same thing as adding a negative. So we could think of this as plus negative 12x cubed, if that helps. If not, we could also always fall back on our calculator. Yes?
Okay, so I got it slightly mixed up. So like the negative 12, I didn't do like a plus sign. So I did like negative 6x like times 12, and then I got 72.
So whenever you're typing answers or problems into your calculator, we only want to use the coefficients, the numbers attached to the variables. You would just type in negative 6 minus 12. If we start putting the x and the cubed in there, our calculator is going to get mixed up. Because remember, these are just variables. We don't want to solve them. We just want to see how many of those x cubes we have.
Wait, how did it become a positive though?
Okay, so let me explain this again. If anybody's confused, why is this plus minus? If I have, I'm going to take away the x cubed for this.
Negative $12, and then you go in the whole $6 more.
Uh-huh.
Get negative 18.
Yeah, so that's, I love the way you explain that. Let's say I owe somebody $6 or I got negative $6 in my bank account. If I then take away $12 more, I'm owing them even more. I'm going to have an even bigger negative number, a negative number with a greater absolute value. So I started with negative 6. I'm taking 12 more away. We're just going to go further negative to that negative 18. Now, we can also think of it like this. This is where I came up with that plus. Negative 6 plus negative 12. To me, sometimes this is a bit easier to imagine because I'm just doing 6 plus 12, but my answer is negative. You see that? Because 12 plus 6 or 6 plus 12 is 18. And since I'm adding negative numbers, I get a negative answer. Does that make sense, you guys? Okay. Okay. All right. So let's get back to our problem. We got this first half taken care of. This, I didn't cross this off. That was done. We were here. We took this down to negative 18x cubed. Done with those. Oh, I didn't mean to cross that off. Guys, I'm sorry. I'm getting ahead of myself. We did these. Okay. Now, we need to mess with 10x minus 6x. Everybody agree with that?
Yep.
Okay, so let's bring that down here. I've got plus 10x minus 6x. All right. What's 10 minus 6?
4x.
Yeah, 4. Positive 4x. You don't want to lose your variable. Plus 4x. So now we're here. Negative 18x to the third power plus 4x. Yes, that is it. That's our answer. We cannot go any further because these are not like terms. They don't have the same exponent. So circle it. That's your answer. We're done. That is it, guys. Very good. Okay, does anybody need to go through one more of these? Or do we want to try, you want to do one more? Okay, let's do one more. One more. And then we're going to move to something different. Oh, does anybody still need to write this? Or can I move it? Okay. All right, so let's try 5x to the fourth power times negative 2x plus 3 plus x times, let's do 4x to the third power minus let's see, 3x. Okay, guys, I'm giving you like a really crazy one for no reason. But you can do this. You can do this. It's the same stuff we've been doing before. Okay. You're welcome to work ahead and do it yourself if you feel super confident, but I'm also going to walk us through it for those of you who want a little guidance still. So, if you are working it out with me, feel free to shout out, what is my first step? Yeah, we're going to distribute 5x to the fourth power over to my negative 2x and my positive 3. So what is 5x to the fourth power times negative 2x? Yeah, we'll start with the numbers. I heard somebody say 5 times negative 2 is negative 10. That's correct. Now what's x to the fourth times x?
X to the fifth is
x to the 5th. Good. Perfect. Okay, I did that. Now 5x to the 4th times 3. So 5 times 3 is 15. And x to the 4th, are we multiplying any more x's? No. So what do I do with that? Bring it down. It just stays how it is. 15x to the 4th power. So we're done with the first half of our expression. What do I do next? Yeah, distribute the next problem here. We've got x times 4x to the 3rd power and x times negative 3x. So what's the first part? X times 4x to the 3rd.
5x squared.
So let's think about this.
4x to the 4th.
Michael, you got it. Michael, you got it. And then I heard somebody else. Was it you up in the front? I think you got it too. So guys, let's think about what's happening here. Whenever we have a variable by itself, like x, we know that that means there is one x here. There's one x here. If I asked you, how many x's do you see right here? 1. So this is really 1x. What is 1 times 4? 4. We don't change that to 5. This is just 4.
Just an extra x.
Yes, the only thing that's changing is we're multiplying x. So we have 4x, and what happens? What's my exponent?
4.
To the 4th power. Good. Perfect. Okay, same thing to the next term. What is x times negative 3x?
Negative 3x squared.
Yes, negative 3x squared. Okay, so we are here. What now? Yeah, why are we going to add 15 and 4? Yes, 15 and 4 are both attached to x to the 4th power. Those are like terms.
19 to the 4th power.
Yes. 19x to the 4th power. That's my middle term. And what do I do with my outside terms? Just bring them down. Awesome. So negative 10x to the 5th plus 19x to the 4th minus 3x squared. And that's it. We're going to circle it. All right. How are we feeling, you guys?
I learned algebra in 2 days.
Yeah, you did. I love it. You guys are doing so well. I mean it. Okay, are we ready for something different?
Yeah.
Yeah. Okay. Here is where we're starting to get a little closer to Algebra 2. This is what we would have been doing in Algebra 1B. Okay, so this is where that second half of algebra would have came in. We're going to start a fresh page of notes here. Fresh page. All right, if anybody needs paper, I've got some up here. If you need a notebook, I got notebooks up there. All right, feel free to take what you need, help yourself. And I will give you guys a moment to get settled, and I'm going to write a title up here. Now, I loved doing this process when I was in high school, mostly because I'm kind of a math nerd. But if you like math, I think you'll like this too. It's kind of satisfying. Multiplying. We're going to call this binomials. And in parentheses, if you're confused about what on earth this means, we'll talk about it, but maybe this next part, something might click in your brain. Foil. You guys remember foiling ever in your life? If you don't, we'll talk about it. This is what we're going to learn today, foiling. It's a fun little trick to multiplying something we call a binomial. Okay. Everybody settled? So first of all, does anybody know what a binomial is? Jeremiah?
It's where it's got two things inside those parentheses, like
Yes.
x squared plus x.
Yes, yes. So a binomial, first of all, let's talk about what each of these parts of the word mean. Bi means two. Yes, exactly. The prefix bi means two. Nomial, if you just did pre-algebra, you'll remember we talked about polynomials and we talked about what nomial means. Do any of you remember what nomial means? Anybody? Say it again. Numbers. Yeah, it just means numbers or terms. So we have two numbers or two terms. So a binomial, for example, would be something like this. X plus 3. That is a binomial. So it's just going to be two terms in parentheses. And the only thing that really matters here is that they are not like terms. They cannot have the same variable for what we're doing. Because if they can be combined, it's no longer a binomial. There's no longer two parts. Okay, so I'm not going to ask you to identify that. I'm not going to say, tell me what a binomial is. I'm just trying to describe what this word means so you understand what I'm talking about. So we have a binomial here. What if I wanted to multiply this times another binomial? What if I wanted to multiply these?
So your x would be like terms, right?
Would they?
I believe so.
Let's think about it. So, if we were adding, yeah, we would have like terms here. I would have x plus x and get 2x, but I want to multiply these. Yes?
Oh, so
If I can remember, do you multiply the first one by each on the second one, and then the second one by each on the second one?
Very close. You're like a centimeter away from being 100% correct there. But you have the right idea, yes. So here's where this word FOIL comes in. I'm going to tell you what this stands for. So F means first. O stands for outer. I stands for inner, and L stands for last. And I'm going to tell you what that means even more once you get that written down. So, if we were multiplying and that x was gone, we would see 3 times the quantity x minus 2. And I think you guys are at a point where you would know, oh, I'm just going to distribute the 3 to both of those. I'm going to multiply 3x. I'm going to multiply 3 times negative 2 and get negative 6. It's very similar to that, only now we have 2 things we're distributing. So here's how this works. And now that I'm thinking about what you said, maybe you did say it correctly and my brain didn't process it quick enough. I think you explained that exactly right. So let's look here. We're going to do the first terms and multiply those. So my first term here is x. My first term here is x. I want to do x times x first. So x times 1 would be 1x.
Oh, so it's
Squared.
Yeah. Oh, x. So x plus x would be 2x.
So x squared?
X squared. Yes, if you multiply something by itself, you're squaring it. So I've got x times x, and I'm going to write these out. X times x, and that is x squared. Now I'm going to switch colors on here because I think it's a little bit of a process and I want you guys to be able to differentiate what I am doing up here or decipher what I'm doing. Okay, so we did the first term. Now we're going to do the two outer terms of our binomials. So my far outer term here is x. My far outer term here is -2. So outer is going to be x times -2. -2x. Good. -2x. And we'll simplify later. I know we've got plus and negative. We'll get rid of that later. Okay, so the next thing in FOIL says inner. So I want to mess with my two inner terms here. The terms on the inside. Let me get another color. So I'm going to do 3 times x. And what is 3 times x? 3x, just 3x. So plus 3x. I'm going to make that, here we go. And now we got to do our last terms. Our last terms. What are our last terms?
3 and -2.
3 and -2. Good. So 3 times -2. And I heard you say it. -6. Good. That's -6. Wonderful. So we did that. Now we want to simplify it. We need to make sure that all of our like terms are combined. We want to make sure we get rid of any unnecessary plus or minus signs. Yes, we have like terms in the middle here. I've got -2x plus 3x. So if I did -2 times 3, I would get -6.
Oh, but you said plus, so they.
Yeah.
So it's a positive.
We're adding here. So if I start with -2, let me make a number line.
-2 plus -3, so it will be 1x.
So it's, look at my signs here. -2 plus 3. It's a positive 3. So -2, -1, 0. Here, I'm going to make a line. -2, -1, 0, 1, 2, 3, 4. Okay, so I'm starting with -2 x's. So here's my starting point. And I'm adding 3. So when I add, I go where the numbers get bigger to the right, plus 1, plus 2, plus 3. How many x's will I have left? 1. 1x. Or you could just write x. Awesome. Does everybody understand that? Okay, good. So -2 plus 3 is 1. You can write 1x, or you can just write x. Okay. Do we have any other like terms? Nope. So what do I do with the rest? Just bring it down. X squared plus x, or 1x. And then I have plus -6. What should I write beside 1x? Just -6. We don't need to write plus negative. -6. And that's my answer. So we circle it. That's right. Awesome. So guys, really what's happening here, we're just doing distribution twice. We're just distributing x, and then we're distributing 3. When we have 2 terms to distribute, we're just doing it twice. Takes a little longer, but we're doing a pretty great job. It's not so bad. Let's do another one. Move that out a little. Okay. And I'm going to zoom out even more in case anyone's still writing. How about we try x minus 3 times x plus 7. Okay, and I'm going to come back in a little for us working that out. And beside it, I'm going to write FOIL so I can remember my trick. Anybody still need the problem from above? Can I move forward? Okay, you sure? All right. We just started on this, Toby, so you're not going to be too far behind. We only did one problem, so you're good. Okay. So, what do I do here? Yeah, my first terms are x and x, so I want to start by doing x times x. And what's that going to give me? X squared. Good. Okay, and what next? Yeah, we're going to do the outer terms, x times 7. Yep, x times 7 is, you are right, star, 7x. I'm going to write that out too. X times 7 equals 7x. I'll put a plus there. Okay, what do I do next? The inner terms, which are? Yes, negative 3 and x. So, negative 3, x. Yes, negative 3 times x is just negative 3x. Are we all okay with me just writing minus 3x? Okay. Minus 3x. And what's my last step? Negative 3 times 7. Good. And what is the answer to that? Negative 21. Awesome. Okay, so we have completed the FOIL process. We've distributed this binomial into the second one. Yes, yes. Don't second guess yourself. You're right. You're right. 7x and negative 3x are like terms. We want to combine those. What is 7x minus 3x? 4x. So, I'm going to rewrite this. X squared plus 4x minus 21. And we circle it. That is it. That's our answer. Good job. Very good job, guys. How are we feeling about this? Feeling good? Feeling okay? Okay, let's do some more. We'll probably run through 1 or 2 more on our together, and then I'm going to have you try some on your own, and I'll come around and see if any of you need help. Okay, I'm going to scooch that up a little. Let's try. Can I give you a tricky one?
No, it's a second to solve it before we discuss it.
Say it again.
Like, can you give like 1 minute to do it? Because while we're trying to do it and I'm going, I'm like.
So what we're doing right now is we're kind of trying to like come out together, and I'm doing the demonstration part here. And then I'm going to give you guys a bunch of time to try it on your own next once I've gotten done kind of guiding you through it. Now, I can absolutely slow down at each step if you want me to.
No, I'm comprehending fully. It's just like when you're trying, when you first put it down and we're trying, when I'm trying to solve the problem and you're explaining the problem, I can't solve the problem in my head because
I get you. I get you. Yeah, absolutely. No, I appreciate you saying that. We can absolutely give a little more time then, for sure. Okay, so does anybody need more time before we start a new one? Anybody need more time? Speak now. Okay, we're moving on. let's try x plus 10 times x minus 5. Now remember, at least what we were doing up here, just trying to guide you through this. You guys want a moment to do this by yourself right now, or do you want me to guide you a few more times? We're going to be silent. Y'all ready? Okay. So, what do I do first? My first terms, what's that going to be? X times x, absolutely, that's x squared. What do I do next?
10 times, x times negative 5.
Yep, my outer terms, x times negative 5, and what is that? Good, negative 5x. What's next? Inner terms. 10 times x, that's 10x. 10 times negative 5, what's that? Minus, oh, so hang on. 10 times negative 5, there's no x there. Minus 50 is correct, yes. Minus 50.
You got two like terms.
Yep, so now we have our like terms in the middle. What is negative 5x plus 10x?
5x.
That is right. We got 5x here.
Bring down 2 of it.
X squared plus 5x minus 50. And we're done. All right. Okay, guys, so here's what I'm going to do for you. I'm going to pass out a worksheet and let you guys try these on your own. I'm going to pause this. All right, so let's look at the first problem together. We are multiplying 4x minus 5 by x minus 3. So, oh, thanks. Thank you for saying something. I had no idea. There we go. All right. 4x minus 5 times x minus 3. What should we do first?
4x first.
Yes, our first terms, which is 4x and x. So, you just said it correctly, absolutely. 4x times x is 4x squared. Perfect. Now we want to do the outer term. Exactly. 4x times what? Negative 3. What's that going to give me? Negative 12. So 4 times negative 3 is negative 12. But what's 4x times negative 3? 12x. We got to keep our variables. So we have 4x squared minus 12x. And what are we multiplying next?
-5 and you're at.
Negative 5 times x. What does that become?
-5.
Good. Negative 5x. And last but not least, our last terms. Negative 5 times negative 3. Two negatives make a positive. Good. Plus 15. Okay.
And your like terms will be your pieces.
Yes. So we have these two terms in the middle with the same variable and the same exponent, which is that invisible 1. So we can combine these. What is negative 12 minus 5? Yes, negative 17x. And drop everything else down. Good job, guys. 4x squared minus 17x plus 15. And then we circle our answer. Yeah, period. Love it. Awesome. Good job, guys. That is wonderful. Okay, let's look at number 2. Before we do, though, any questions on 1? Okay.
I missed the step, so I messed up. I didn't get that answer. My
Ooh.
number is wrong. I see what I missed.
You did? So what step did you end up missing?
4x times the 3.
Ah,
Yeah.
those outer terms. Yeah, it's super easy to miss one.
Yeah,
Ah,
I did that.
and that's okay. See, that's why we practice. That's why we practice.
That's right.
And you guys, I want you to keep in mind, this is the very first day that I've ever introduced this to you. So the fact that we're even kind of getting it is great. You're on an excellent path. I don't expect you to be professionals yet, okay? We're learning. We're learning. Let's look at number 2. What should I do first here?
First.
Yeah, my first term's 4x times x, which is?
4x squared.
Good. 4x squared. And then what do I do next?
4 times negative 4.
Yeah, 4x times negative 4. What's 4 times negative 4? Negative 16, and I've got an x. So I do what? I just bring that x over here on the 16. 4x squared minus 16x. What's next?
Negative 4 minus.
Yep, negative 4 times x is negative 4x. And last but not least, yes, negative 4 times negative 4 is positive 16, plus 16. And what do I do next now, guys? I've got my, I got some like terms in the middle. Negative 16x, negative 4x. What happens? Oh, so if we multiply two negative numbers, we get a positive. But what if, remember, when we add and subtract. Negative 20x. So I always like to think of negative numbers as money. Like if I owe somebody $16 and then I lose $4 more, I'm now $20 negative. I'm totally lost. I did not gain any money. I just kept losing. So that negative gets bigger. 16 plus 4 is 20. So negative 16 plus negative 4 is negative 20. Negative 20x. And the other terms, what do we do?
One down.
Just bring them on down, yes. 4x squared minus 20x plus 16. And that's our answer.
Was this for grade or?
This is just practice today. Normally the only things that I will grade for accuracy in this class is your exit tickets and your quizzes and your final at the end of the unit. So anything that we do together in class where I go over the answers, just for participation and effort. Sound good? Okay. All right. Let's look at number 3. And we're getting really close to the end here, guys. This will probably be the last one we go over on the worksheet. We'll do some more of this tomorrow.
I'm going to take my blank one home and compare my answers.
Sounds good. Sounds good. All right. Number 3, what are we doing?
2x times 3x.
2x times 3x is? Yeah, 2 times 3 is 6. X times x is x squared. Good.
We're on the wrong column, my bad.
Oh, yeah, we're on number 3. That's okay. That's okay. So we did 2x times 3x to get 6x squared.
And then you would do your outside.
Yep, now we're going to do the outer term. 2x times 5, you are correct, 10x plus 10x. Now let's do our inner term. Yeah, 6x. So 2 times 3 is 6, but there's an x, so we put that on there. And last but not least, yeah, 2 times 5 is 10. Yeah.
And then your like term would be 16x.
Good. Yeah, 10x plus 6x, that's 16x. Good. Plus 10 plus 6x squared. Awesome. Okay, guys, we're going to do more of this tomorrow. We'll do lots of practice. This is new. You all are doing really, really well. I'm going to give you an exit ticket. It's just going to be one problem. So you're welcome to finish it before you go, but remember, exit tickets are never due until the week after I assign them. So I want you to label your paper for me so I can keep track of the grade book. Oh, hold on. This is day 3. So I want you to label this as day 3. Oh my goodness. I want to just be blurry. Come on now. Okay. Day 3, exit ticket. And please write your name on your paper so that I can give you credit. Okay, so for your exit ticket, I want you to do x plus 3. I'm going to give a slightly more simple one for our exit ticket. We'll get more complicated later on. Times x minus 6. And that is it for your exit ticket. So I'm going to freeze this screen for a moment so that I can put my hand over the paper and not block the problem. Let's see.